Okay, now let's see what we are going to do today. We will study this. We'll just finish this topic of the skewing model. Okay. So one formula we had to see what is the probability of n arrivals in time t. We have to see how many people. What is the probability of n arrivals at time t? So for that we have one formula that I would like to write it here. Probability. Okay, we can write it as like this. Probability of n arrivals in time t. This is equal to e raised power minus lambda t raised power n divided by n factorial. So please remember this formula. It gives us the probability of n arrivals in time t. Suppose if you have to see what is the probability that three customers probability that three customers will arrive in suppose 10 minutes. Okay, so let us suppose find the probability that three customers will arrive in 10 minutes. What is the probability? That means three. What is the probability that three customers arrive in 10 minutes? Okay, this will be equal to e raised power minus lambda. Okay, suppose the lambda is given as 8 customers per hour. Okay, it is given as 8 customers per hour, but you have to take care that since it is asking what is the probability that 3 customers will arrive in 10 minutes, therefore you have to convert this lambda also into the minutes. This will be equal to 8 customers per hour means 60 minutes. Okay, this will be equal to 4 by 15. The value of lambda will be equal to 4 by 15 customer per minute. So this means that e raised power lambda is 4 by 15 customers per minute, and this t time interval that we have to see is of 10 minutes into lambda. Again it is equal to 4 by 15, and this interval we have to see for 10 minutes divided by raised power n here is 3. 3 factorial means 3 into 2 into 1. So this way you can find what is the probability of n arrivals, any number of people arriving in any given instant of time. Okay, so this is one formula that you must remember. You must remember that the arrival process follows the Poisson's distribution, and अगर आपने Poisson distribution पढ़ा होगा तो आप देख सकते हो कि this equation resembles to the Poisson distribution equation. Okay, I hope you have studied the probability distribution in the 4th sem mathematics. So this formula gives us what is the number of people that can arrive within a given number of time. Probability of arrival of n customers in a given time t. This will be the formula which will be used. Okay. Now, one very important thing that we have to study is the inter-arrival. We will study inter-arrival. Okay, and you know that inter-arrival is, we can say, that time between two consecutive arrivals. Time between two consecutive arrivals. Okay, so you can see that if there is a system where the services are being provided, suppose this is any system. Here we have a server. Here is a server, and there are people waiting in the queue. There are people waiting in the queue. Suppose there is a person which is observing this system. Okay, this person is a observer which is outside the system. He sees that at 9 p.m. suppose at 9 p.m. suppose this is an ATM. He might have started his observation sometime, back, वो देखता है कि 9 बजे एक कस्टमर आया यहाँ पे, 9 बजे एक कस्टमर आया यहाँ पे. Okay, one customer has come to withdraw the money in the ATM. Now he is in the queue. Suppose he is in the queue. He says he sees exactly at 9 p.m. one customer has arrived in the queue. Now when this new customer will arrive, when the new customer will arrive, he will start observation here at 9 p.m. At 9 p.m. this observer will start his observation that he will see that कि 9 बजे एक यहाँ पे कस्टमर आ गया. अब कितने समय बाद किस टाइम पे अब नया कस्टमर आएगा, that will be the inter arrival time. That will be the inter arrival time. That is time between two consecutive arrivals. One customer arrived at 9 p.m. Now he is observing when the new customer will arrive. Suppose the new customer arrives at 9:10 p.m. Then we can say that 10 minutes is the inter arrival rate. 10 minutes is the inter arrival rate. Okay, so one thing is arrival rate, which is the how many customers are arriving per unit of time. But this means that inter arrival rate means after how much amount of time a new customer comes. Therefore the unit of it is the time per customer. Okay, I have discussed it so many times. The unit of it is time per customer. Here we can say that the inter arrival rate, if I want to write the inter arrival rate for this system here, we can say that it is suppose 10 minutes per customer. Okay, again this inter arrival system is not we can't say that it is some deterministic, but it definitely follows some probability distribution. It follows some probability distribution. And remember this very important point here, the distribution followed by this inter arrival is negative exponential. The distribution followed by the inter arrival. So arrival follows Poisson distribution. Arrival follows Poisson. But inter arrival, when I talk about the inter arrival distribution, this is the negative exponential distribution. Okay, this is the negative exponential distribution. So arrival pattern needs two terms, number of persons and the time t. Okay, arrival pattern. So if you have to see the arrival pattern, you have to see how many people are coming and in what time they are coming. But here in this case, we need only the time t. Okay, we don't need to see the number of persons because we will observe on the basis of one person. We have to see after how many time a person comes. Therefore we don't have to see the number of people arriving in some time t, but we have to see after what time a person arrives, or we can say that what is the time between two successive intervals. Okay, so we don't have to deal with the number of persons. Therefore in this case the inter arrival distribution is negative exponentially distributed. So let me write what we have studied. We have studied that arrival pattern follows Poisson distribution. These are very important questions for objective. Many times they are asked in the competitive examination. Arrival process follows Poisson distribution, but inter arrival follows negative exponential, and service follows negative exponential. Service follows negative exponential, while as inter service follows Poisson. Okay, so abhi tak, before this lecture you had studied the distribution of arrival and distribution of service. So you have remembered that arrival follows Poisson, but its inter arrival will follow negative exponential. Similarly, you knew that the service pattern is negative exponential. Service pattern is negative exponential, but its inter service will be Poisson distributed. Okay, so these four things you have to remember for the objectives. These are directly asked in the objective questions. As objective questions, they are directly asked. So this is the negative exponential, which is the probability distribution of the inter arrival. Okay, so we'll spend some more time on it. So you can take the screenshot up to this point. inter-arrival rate. So I told you this follows the negative exponential distribution. It follows the negative exponential distribution. And if you remember what you have studied in the past, the negative exponential distribution, this is the negative exponential distribution probability density function. Lambda is equal to e raised power minus lambda t. This will be the probability distribution of the probability density. In fact, I can say that this will be the probability density of inter-arrival, because it is negative exponential distribution. This is the probability density of inter-arrival. So don't confuse the probability and probability density. Probability density is a function, while probability is given by the integral of that, okay. So I will show you that what will the graph look like. This is time t, and this is the axis of the probability density function. Okay, so these things you have studied in the mathematics. This is the probability density function, and here we have the time. And you know that the negative exponential curve will look like this. This will be the negative exponential distribution curve. Okay, so to find the probability, to find any kind of probability, what we do is that we just integrate this thing. Okay, the area under this curve will give us the probability. The area under this curve will give us the probability. So let me integrate it from 0, time equal to 0, to time equal to suppose infinity. Can anyone say what will be this integral equal to? Without just evaluating it, can anyone say what should be this integral equal to? I'm integrating it from the time limits 0 to infinity. Now I hope you have studied this in the mathematics. What will be the integral equal to? I don't know why you are not answering, but this should be equal to 1. This should be equal to 1. Okay, so this is the probability density function. This is the probability density function. To find the probability, we need to integrate it within some limits. Okay, so suppose someone asks, what is the probability of an arrival? What is the probability of an arrival in suppose time t? Suppose this is the time t. Okay, suppose this is 9 p.m. Suppose this is 10 p.m. Okay, so he says that what is the probability that a customer will arrive? What is the probability of the inter-arrival? Inter-arrival time is t. It is the capital T. It is the time capital T. What is the capital T? Okay, just wait 1 second. So I was talking about this. This T is the inter-arrival rate. Inter-arrival rate means after how much time, or time between the two successive arrivals, or we can say that after how much time and now new customer arrives. A customer has arrived, now after how much time a new customer will arrive. So suppose this time is equal to 9 p.m. Suppose this time is equal to 10 p.m. Okay, again we don't know when the customer will arrive. One customer has arrived, we don't know after how much time will the new customer arrive. Therefore this becomes the capital T, and this capital T here is now equal to suppose 1 hour. Okay, this time equal to 0 is 9 p.m. and this time is equal to 10 p.m. Therefore this time elapsed is 1 hour. Anyone wants to see that what is the probability that a new customer will arrive in 1 hour? Okay, so this is the time equal to 0, this is the time equal to 1 hour. Then what is the probability that the inter-arrival rate will be 1 hour? What is the probability that the inter-arrival rate will be 1 hour? Then we have to see the area under this curve. we'll have to see the area under this curve. This curve area will give us this curve, the area of this curve will give us the probability that the inter-arrival rate is 1 hour. Okay, and this will be obtained by integrating this probability density function. This is the probability density function. This curve is the probability density function. That is, it is equal to lambda e raised power minus lambda t. This is the equation of the curve. Okay, so this is what we mean by the probability density function, but the probability will be obtained by integrating it within certain limits. Okay, this area will give us the probability that the inter-arrival rate will be 1 hour. So this is equal to lambda e raised power minus lambda t. We have to integrate it from 0 to 1 hour. Okay, so we are integrating from 0 to 1, then this lambda should be in customer per hour. This arrival rate should be in terms of per hour. Okay, so I hope you understand what is going on here. So we have seen that the जो inter arrival rate का pattern होता है, that is negative exponentially distributed. If there is some time, I will say you why this is negative exponential distributed. But this represents the curve. This represents this curve, the equation of this curve, which is the negative exponential curve. Okay, to obtain the probability of certain inter-arrival. Now we don't know what is the inter-arrival rate. We don't know what is the inter-arrival rate. We don't know what will be the time between two successive arrivals. Therefore, again, this will be a probability. This again will be a probability. So by this thing, we can calculate what will be the probability of the inter-arrival time having this. Okay, what will be the probability of inter-arrival time of 1 hour? What will be the probability of inter-arrival time of 1 hour 30 minutes? And what is the probability that inter-arrival time will be of 1 hour 30 minutes? Then we have to see the area of this graph up to this graph. इस पूरे ग्राफ का हमें इस पूरे कर्व का हमें एरिया जो मिलेगा इस पॉइंट तक, that will be the probability of the inter-arrival time being of 1 hour and 30 minutes. Now suppose if you had to see what is the probability of inter-arrival time being between 1 hour and 3 hours. If you had to see what is the probability of the inter-arrival time, क्या probability है कि inter-arrival time is between 1 hour and 3 hour. Then how will we evaluate this thing? Suppose this is equal to 1 hour, this time is equal to 1 hour, this time is equal to 3 hours. Then what is the probability? क्या probability है कि inter-arrival time होगा between 1 hour and 3 hour? Because we don't know what is the inter-arrival time. But what is its probability that it will be between 1 hour and 3 hour? Then this area will give us the probability that the inter-arrival time is between 1 hour and 3 hour. So this will be obtained again by probability that inter-arrival time is between 1 hour and 3 hour. Then this will be given by the integral of the same function. But the time limits will be from 1 to 3. The time limits will be from 1 to 3. Okay. So this is what is the fun of the inter-arrival rate. Its probability density function is negative exponential, which is given by this function. This function gives the negative exponential distribution. And to obtain the probability of what can be the inter-arrival time, okay, we don't know what is the inter-arrival time, but what can be the inter-arrival time, that will be given by the integral of this probability density function, and that is given by the area under this curve of the curve is between the time and the probability density function. Okay, I hope you got it. So can anyone tell me, if I have to find the probability that the inter-arrival time will be greater than 3 hours? I tell you one question, what is the probability that inter-arrival time is greater than 3 hours? Then what should be my limits? Okay, the integral we have to always take of this function. The integral हमें इसी function का integration हमेशा करना है. But can anyone say what will be the limits if I have to see what is the probability of the inter-arrival time being greater than 3 hours? What will be the limits there? Yes, exactly. Z 3 to infinity. It will be from 3 to infinity. Greater than 3 hours means that this much area. Okay, this area. It will give us the probability that the inter-arrival time is greater than 3 hours. Okay. So I hope you got the concept of inter-arrival time and how to find the inter-arrival time. So you can copy this much. Suppose this is an ATM. Okay. Here is the ATM machine. There are people waiting in the queue. There are people waiting in the queue. Okay. Suppose one student of your class, suppose Umar is here observing the system. He's the observer. The observer should not be a part of the system. He has not to be the part of the system. Suppose Umar sees that at 9 p.m. a customer has arrived in the ATM. Okay, he sees that at 9 p.m. a customer has arrived in the ATM. Okay, so now we tell him to observe the system. Okay, he exactly sees that at 9 p.m. 9 बजे ये exactly देखता है कि एक customer आ गया है system में. Now हम इसको कहेंगे उमर को observe that when the new customer arrives. I will tell him that see when the new customer arrives. Okay, so he will tell me, sir, I will look for only 1 hour. I will just observe for 1 hour. I will be here watching this system for 1 hour. मैं 1 घंटा ही यहाँ पे रहूँगा. After that, I will leave. Okay. So suppose this is 9 p.m. This origin is 9 p.m. Suppose this is any instant of time. Suppose t. Suppose this is any instant of time t. And suppose this is 10 p.m. That is this much amount of time is the 1 hour time. Okay. जिसमें ये observation करेगा. He has said to me that I will observe the system only for the 1 hour. After that, I will leave. Okay. Now there are two possibilities. During this observation time, a new customer can arrive, or during this observation time, a new customer cannot arrive. Now I am not telling him कि पूरा 1 घंटा यहाँ पे बैठो. I am not telling him कि पूरा 1 घंटा यहाँ पे बैठो. देखिए अगर customer आया at 9:10 p.m. If the new customer comes at 9:10 p.m. Okay, that means if the customer comes here at after 10 minutes, now there is no fun of Umar being in this watching this system again, because I have got a kind of an inter-arrival rate. That is, I will say that the inter-arrival rate is suppose 10 minutes. Okay, I am just telling him that कि आप देखो यहाँ पे बैठो कि नया कस्टमर कब आएगा. See when the new customer will arrive. He says that कि मैं 1 घंटा वेट करूंगा. अगर कोई आया तो मैं आपको बताऊंगा कि इतने मिनट बाद ये कस्टमर आया. अगर 1 hour तक नहीं आया, then I will leave the system. I will stop observing this system. Okay. Therefore it's not necessary कि ये यहाँ 10 बजे तक बराबर यहाँ पे रहे कि it's not necessary that he will stay here for 1 hour exactly. Okay. If a customer comes within few minutes, he can leave the system. He can just stop observing. He will report me that the customer has come at this much amount of time. Now there are two possibilities. One possibility is that within this frame of time, within this time span, a customer can arrive, or customer can arrive after this. Okay, a customer can arrive up to time t, or a customer can arrive after time t, after this observation time. So there are two conditions. या तो ये कंडीशन है कि इसी टाइम स्पैन में एक कस्टमर आ जाए, या इस टाइम स्पैन में कस्टमर नहीं आ जाए जिसमें ये स्टूडेंट ऑब्जर्व कर रहा है सिस्टम को. सो वी कैन से दैट arrival will occur at time equal less than t, less than or equal to t. ठीक है, within 1 hour or less than 1 hour. अगर टाइम उस टाइम में कोई कस्टमर आया, we can say that the arrival has taken place. We say that he will say that no arrival occurs. He will say that no arrival occurs if this time is greater than t. And this time is a variable. this can be here, this can be here, this can be here, this can be here. This small t is less than this t means that an arrival has taken place. Then we can say that if the arrival has taken place, then this t is less than this observation time. If no arrival has taken place, then time तो यहाँ पे होगा कहीं पे, यहाँ पे होगा कहीं पे, यहाँ पे होगा कहीं पे किसी भी, but that will be greater than t. So we can say that no arrival has occurred. Okay. So what is the probability of arrival? Let me check what is the probability of arrival. What is the probability of arrival? Probability of arrival will be given. Probability of arrival will be given by this will give the probability of arrival lambda e raised power minus lambda t dt के टाइम लेस देन और इक्वल टू टी में ही अराइवल हो गया. ओके, टाइम लेस देन और इक्वल टू टी में ही अराइवल हो गया. ओके, so this will give us the probability of arrival at time t. This will give us the probability of arrival at time t. So if we evaluate this integral, we can say that if we evaluate this integral, this will be lambda e raised power minus lambda t divided by minus lambda. The time of integration will be from this to this, and this will be equal to minus, if we give the limits, e raised power lambda t minus e raised power 0. So it will be equal to e raised power 0 is equal to 1. It will be equal to 1 minus e raised power minus lambda t. Okay, so it will give us the probability that time t tak, it will give us the probability कि time t तक कोई arrival हुआ है. Okay, it will give us the probability that there is a possibility that within the time t there will be an arrival. So if we had to see that there is no arrival up to time t, no arrival, then we will just simply, this probability will be equal to 1 minus, है ना, या तो कोई एक अराइवल हुई होगी यहाँ तक टाइम टी तक, या कोई अराइवल नहीं हुई होगी. देन दीज टू प्रोबेबिलिटीज, probability of arrival plus probability of no arrival, this will be equal to 1. Probability of arrival is equal to 1 minus e raised power minus lambda t. Probability of no arrival will be 1 minus probability of arrival. Therefore 1 minus probability of arrival, this will be the probability of no arrival up to time t. That will be equal to, from here we can clearly see that it will be equal to e raised power minus lambda t. Okay, it will be equal to e raised power minus lambda t. You have to remember these two formula as well. So what we have seen that the probability distribution function, the probability distribution function of the arrival pattern is negative exponential distribution, that is given by e lambda raised power e raised power minus lambda t. Okay, where lambda is the arrival rate. Okay, now to find the probability of what is the probability that the inter-arrival time can be up to this t, that will be given by the integral of which is the area under the probability density curve, which I had discussed it in the previous session. Okay, so also we had seen that at the last we had seen that what is the probability that inter-arrival time can be this we had seen that this is equal to, this evaluates up to 1 minus e raised power lambda t, which says that, okay, what is the probability of having this as the inter-arrival time? This will be the probability. And what is the probability that the inter-arrival time is greater than some value of t? Then that will be equal to e raised power minus lambda t. This will be the formula of it. Okay. So the theoretical discussion has, we have just completed this unit now. Everything that needed to be discussed has been discussed in this unit. So today I had just discussed this function. Okay. So one thing was the probability that there will be n arrivals in time t. That formula I had written that will be equal to e raised power minus lambda t raised power n by n factorial. Okay, this is related to the arrival rate. This is related to the arrival rate because it considers how many customers are arriving in time t. That thing has been discussed in the arrival rate. Therefore, it includes the number of customers as well, number and the time as well. But you can see that this distribution here, so this is the distribution. This is not the probability. This is the distribution, probability distribution or probability density function. This is the probability density function, while as this is the probability itself. This is the probability itself. Okay. Now these two things are the probabilities, but this is the probability distribution. And if you have to follow, if you have to evaluate the probability, then you have to integrate this because this is the probability density function, not the probability itself. But this thing here, this thing is the probability itself. That what is the probability of n arrivals in the time t? This gives us the probability. But this is the probability density function, and to get any kind of probability from this function, we have to calculate the integral of it. Okay, we have to evaluate it. This means the probability, but this means the probability density. So I hope this thing is clear to you. And you can see that यहाँ पे n का जिक्र ही नहीं होता है. What is n? Because we always talk about the inter arrival rate. जब हम डिस्कस करेंगे कि एक कस्टमर, यहाँ पे एक कस्टमर आया है, यहाँ पे अब दूसरा कस्टमर कितने टाइम के बाद आएगा. So this is about the inter arrival rate. Okay, inter-arrival rate will depend only upon this arrival rate. Can you see this Word document? Are you able to see this Word document? Okay, suppose one question was asked. The arrival of customers in GATE 2018, the arrival of customers over a fixed interval of time follows a Poisson distribution with an average of 30 customers per hour. Okay, so the lambda is given here, that the lambda is equal to 30 customers per hour. What is the probability that the time between successive customer arrivals is between 1 and 3 minutes? Okay, so I have discussed it. He talks about this curve. यहाँ पे देखिए clearly he mentions that what is the time between successive customer arrival. That is, what is the probability that the inter-arrival rate is between 1 minute and 3 minutes. He's talking about 1 minute and 3 minutes. Therefore, let this be the time interval of 1 minute. Let this be the time interval of 3 minutes. Therefore, what we have to do here is just integrate it. This will give us the probability that the inter-arrival time, or the time between two successive customer arrival, is between 1 minute and 3 minutes. So if we integrate it, we have to take the integral of this function. This function is again lambda. Therefore, the probability that the inter-arrival is between 1 minute and 3 minutes, that will be given by, this probability will be given by integrating between 1 minute and 3 minute lambda e raised power minus lambda t dt. This will be equal to 1 to 3 lambda. See here, this customer per hour, this arrival rate is given in the customer per hour, but we have to see the inter arrival rate is in the minutes, 1 minute and 3 minutes. Therefore we have to convert this 30 into the per minute. This will be equal to 1 by 2 customer per minute, or 0.5. 30 customers are coming per hour. There are 30 customers which are coming per hour, but one customer, 1 by 2 customers will come in 1 minute, or half of the customer will come in the 1 minute. Therefore this will be equal to 0.5 e raised power minus, we can perform this integration, that will be equal to 0.5 e raised power minus 0.5 t divided by minus 0.5, and the limits of integration will be from between 1 and 3. Okay, so this will be equal to minus e raised power so you can evaluate this integral and find the probability. Okay, you can solve it and find the probability itself. Okay, see one more question. For a server poison arrival, for a single server with poison arrival and exponential service time, the arrival rate is 12 per hour. This is the lambda. Which one of the following service rates will provide a steady finite queue length? Okay, just answer me this question. The arrival rate given is 12 per hour. Okay, 12 customers are coming per hour. Which service rate, what should be the service rate so that we can get a finite queue length? It's very much simple. You can answer it directly. Finite queue length कब बनेगी? What should be the service rate? Can anyone answer? I mean, you? It's pretty much straightforward. Finite queue length कब बनेगी? Study finite queue length. I have discussed it. लैम्डा ज्यादा होना चाहिए कि कम होना चाहिए? फाइनाइट क्यू लेंथ कब बनेगी? जब मैंने कहा था कि सर्विस सबको मिलेगी. Can anyone answer? Okay, so answer is this here. Regarding this thing, you can evaluate this. Okay, आपको सिर्फ कैलकुलेटर पे सॉल्व करना है. Now, can anyone tell me what is e raised power infinity? Because कभी यहाँ पे टाइम इंटरवल में ये भी आता है. What is the probability? Suppose he had asked what is the probability that this what is the probability that the arrival, this inter arrival time is greater than 3 minutes, then हमें 3 से infinity पे इंटीग्रेट करना था, तो एक लिमिट आ जाती e raised power infinity माइनस सपोज e raised power 3 कुछ आ जाता है यहाँ पे. So do you know what is e raised power infinity equal to? e raised power infinity is equal to 0. ठीक है, तो कभी अगर ये भी आ जाए ना किसी क्वेश्चन में आ सकता है, what's the probability that the inter arrival time is greater than 5 minutes, 10 minutes, greater than 5 minutes, that means 5 to infinity हमें इंटीग्रेट करना है. तो e raised power infinity की भी एक लिमिट आ जाएगी, that is equal to 0. e raised power infinity is equal to 0 and e raised power 0 is equal to 1. Okay, कभी ये भी आ सकता है, what is the probability that the inter arrival rate is 3. तब हमें 0 to 3 इंटीग्रेट करना है, तो e raised power 0 होगा, that will be equal to 1. e raised power infinity is equal to 0. Okay, this is a simple problem. Lambda is given, service rate is given. What is the expected time that a customer is in the queue? Expected time that the customer is in the queue is the waiting time in the queue. You can easily find it out. Okay, see, one question is on the basis of notation. This is the notation. What does B and D stand in this notation? मैंने आपको ये भी डिस्कस किया है. This is the Kendall notation, so you can answer me how we represent the queuing model. ये Kendall का notation है. A, B, C, D, E, F. So what does these things represent? B and D. In this question, he has asked what does B and D represent? What should be the answer of this question? Continuously पढ़ते नहीं हो आप. I discussed a few days back what are these things. जो मॉडल हम पढ़ रहे हैं that is M1 FIFO infinity B. ये मैंने कहा था ये अराइवल का पैटर्न है. This gives us the service pattern, service distribution. This is number of server. This is queue discipline or service order we can say. ठीक है. So this is D, service time distribution and queue discipline. This is the capacity of this system and this is the capacity of calling population. So the answer is A. Simple things. You can answer this question easily. The jobs arrive at a facility for service in a random order. What is the probability distribution of the number of arrivals of a job in a fixed time? He's talking about the number of arrivals in a fixed time. अभी मैंने 4 बताए थे कौन से में क्या होगा distribution. So what is the answer of it? This will be poison. Okay, अभी मैंने कहा था कि ये बात कर रहा है number of jobs in a fixed time. What are the number of jobs in a fixed time? Jobs per time or customer per time, it represents the arrival rate and arrival is poison. अगर ये बात करता what is the probability distribution of the time between successive arrivals, तब वो होती बात किसकी inter arrival rate की, तब आता negative exponential. But this will be poison because he is talking about lambda. Because sometimes I'll discuss this question here. Jobs arrive at an average of 5 in an 8-hour shift. Okay, तो किसी कंपनी में 8 आवर शिफ्ट होता है, मतलब दिस कंपनी वर्क्स फॉर 8 hours per day. Jobs arrive at that in at the rate of 5 in 8-hour shift. That means 8 घंटे में कितने jobs आते हैं? 5 jobs are coming in 8 hours. So in 1 hour 5 jobs will come, that is 5 jobs per hour. So this will be the lambda because jobs per hour is the arrival rate. 8 hours में 5 आते हैं तो 1 घंटे में 5/8 आएंगे. Okay, 5/8 jobs will arrive per hour. The arrival of the jobs follow Poisson distribution. The average service time of a job on the facility is 40 minutes. Now tell me what is this 40 minutes? Read this statement carefully. The average service time of a job in the facility is 40 minutes. What is this 40 minutes which is given in the question? Average service time of a job in the facility is 40 minutes. क्यू टाइम कहाँ से? दिस इज द सर्विस टाइम, एवरेज सर्विस टाइम खुद से ही लिखा है ना, दिस इज द सर्विस टाइम। एक जॉब को 40 मिनट्स लगते हैं सर्विस टाइम के लिए। हाउ मेनी टाइम्स इट इज? इट्स नॉट द सर्विस रेट अगेन, इट्स द इंटर सर्विस रेट। We are finishing this unit today and still you are not able to get the terms. सर्विस टाइम ऑफ ए जॉब, एक जॉब को कितना टाइम लगता है? अगर ये पूछता कि कितने जॉब्स को एक यूनिट टाइम में कितना लगता है, बट ही इज टॉकिंग अबाउट 40 मिनट्स एक जॉब को लगते हैं, दैट इज सर्व करने में। सर्विंग time is 40 minutes per job. This is the inter-service rate. Therefore, mu will be 1 by 40 minutes, or we can say that 60 by 40 jobs per minute. Sorry, per hour. अब मैंने hour में इसको convert किया है. That will be equal to 3 by 2. This is the service rate. Mu is equal to 3 by 2. Okay, so we have to find what in this question. In this question, it is asked to find the service time follows the exponential distribution. What is the idle time? आइडल टाइम क्या है, मतलब बेकार टाइम क्या है वहां पे, ठीक है। तो फॉर दैट थिंग यू मस्ट नो व्हाट इज रो। रो इज लैम्डा बाय म्यू। रो इज लैम्डा बाय म्यू, दैट इज इट गिव्स अस 5 by 8 divided by 3 by 2. So this will be equal to, I think, 5 by 8 into 2 by 3, that will be equal to 5 by 12. And I have calculated rho. This is the utilization factor. This gives the percentage of the time in which the server is busy. Okay, I had told you that rho is lambda by 2. This is the utilization factor of service factor. It gives us what is the probability that the server is busy, or what is the percentage or fraction of the time during which the server will be busy. This much amount of time the server will be busy, he will be free for 1 minus 5 by 12. That will be equal to 7 by 12. है ना, 5 by 12% of time के लिए क्या होगा? The server will be busy because rho is the service factor or the time during which the server is busy. But 7 by 12 will be 1 minus 5 by 12, that is equal to 7 by 12. इस percent of time के लिए क्या होगा? Server will be free. 7 by 12 multiplied by दिन में कितना काम हो रहा है, कितने घंटे काम हो रहा है? 8, है ना। 7 by 12 of 8 hours, that is, this will give the total time during which he will be free. Idle time, idle time, that will be equal to 2 by 3, that is equal to 14 by 3 hours. For the 14 by 3 hours, this server will be idle. ठीक है, ये फ्रैक्शन देता है, ये फ्रैक्शन देता है। अब कितना टोटल आवर हमें निकालना है? वी डोंट हैव टू फाइंड द फ्रैक्शन, वी हैव टू फाइंड टोटल आवर्स। देयरफॉर फॉर दिस फ्रैक्शन 7 by 12 ये फ्री होगा, 7 by 12 ये फ्री होगा। 7 by 12 into 8, बिकॉज 8 घंटा है शिफ्ट का टोटल। सो 8 घंटे में ये 7 by 12 of 8 hours, this time he will be idle. अगर ये कहाँ होता है, इसके बदले यहाँ पे बिजी दिया होता, व्हाट इज द बिजी बिजी टाइम? सो 5 by 12 इंटू यहाँ पे 8 हो जाता। I hope you got this question. Some questions are very simple. What does this quantity mean? यहाँ पे कुछ लैम्डा दिया होता है, लैम्डा और म्यू हर क्वेश्चन में दिया होता है, suppose. But what does this quantity mean? Can anyone say? The mean steady number of jobs in the system. What does this thing mean? Mean steady state नंबर ऑफ जॉब्स इन द सिस्टम, ये कौन सी टर्म है? हमने बहुत सारी टर्म्स देखी हैं, LS, LQ, WS, WQ, रो। व्हाट डज दिस मीन? Number of jobs in the system, what does this thing mean? This is not the queue length, this is the length of the system. System की बात कर रहा है, number of jobs in the system, number of people in the system, number of customers in the system, number of machines in the system. This is the length of the system, ls, that is given by rho by 1 minus rho. अगर यहाँ पे q लिखा होता तो lq हमें निकालना था, that would have been rho square by 1 minus rho. Clearly see the question, what is mentioned in the question. Average waiting time, that is in the queue, average waiting time in the queue, wq. Average waiting time in the queue, again this question, average waiting time in the queue. Now can anyone tell what is the answer of this question? This too I have discussed. Little's law gives the relation between what? I had told you that Little's law gives the relation, that is length of the system is equal to, or length of the queue is equal to lambda into wq. Gives the relation between the waiting time and the length of the queue or system. Can anyone answer this question? In MM1 model, we are studying MM1 model, the number of arrivals in an interval t is Poisson random variable. That is, this gives us the probability of n arrivals in time t. What is the probability density function of the inter arrival? आज ही पढ़ा ये probability density function of the inter arrival. C. This is the probability density function of the inter arrival, and this gives us the what is the probability that n people arrive in time t. This is related to the arrival. This is related to the arrival rate, but this is related to the inter arrival. Probability density function of the inter arrival. Okay, so more questions we are asked.